All right, we're set. Let's get rolling. Welcome to the data collector breakout session. Hopefully you're here because you want to learn about all the new stuff that we're doing in pulling in cloud log sources and structured logs. If not, I won't be offended if you leave at any time during the presentation. But this is me. I'm Bruce DeKine. If I shave part of this beard off, I'm the technical product manager for data collection and processing. So this new data collector is one of my projects. With me today, I've got a cohort of helpers. We've got Pete.
I'm a sales engineer. If you're anybody from Wisconsin and Illinois, I'm the guy that you pick on when people work.
And we've got Larry and Eric from our product management department. So they're working with a lot of customers to figure out what our top priorities are to go after as we start to onboard new log sources. So let's kick it off with the state of affairs. Where are we today? And I think for log collection, the world has changed in the past 10 years. We started out with standardized log sources where we'd have a generally unstructured log, but it would come in over a standardized interface like a syslog or event log or a flat file. But the rise of cloud applications have really changed all that. So now we have the opposite. We have structured logs like JSON, but they're coming over non-standardized interfaces like APIs. And so that's caused is a commoditization of log collection. The attitude of the industry seems to be, let's just get this structured data in and we'll figure out what to do with it later on. And that's great in terms of auditability and getting logs into the system, but if you're trying to do any sort of analytics, search, or correlation across workloads, it can present a real challenge. Now, Logarithm, on the other hand, has incredible process log data with our machine data intelligence, but for that, we've sacrificed a little bit of time to market, especially when it comes to API-based sources. So how do we bring those two together and get the best of both worlds? How do we use Logarithm's machine data intelligence and schema while still getting things out the door quickly and getting you the interfaces that you need with the process data quality you expect? And that's where we landed with some immediate goals. So if you attended the cloud presentation earlier today, I put a couple of these up here because it's very relevant to cloud. First of all, we know that as soon as Logarithm 8 comes out, you're not all going to upgrade the first day. There are other realities there. And furthermore, it's not going to come out for a couple months. We don't even have a date set for it yet. So we want this to be backwards compatible with everything 7.2 forward. We do also want to decouple log collection and transformation. So today we hard code that transformation of a structured object to a message that gets sent down to the SEM into the agent. And what that means is if we want to change some of the MDI or do a difference in transformation between two log types, or just be agile in terms of what you're able to accomplish, we can't do that today. So we want that transformation to be independent. We want to immediately support interfaces like Azure, G Suite, Google Apps, Google Compute. How many folks here are on Azure today? Wow, a lot of you. How many on GCP? Couple. And G Suite or Google Apps? A couple more, and I've talked to some customers throughout the week that are on Google Apps. It seems like they're finally starting to eat into Office 365 space. So that's exciting for competition in the industry, but we would love to be able to support better G Suite logging. Cisco AMP for endpoints is another one that I think we have some PowerShell scripts out there to pull logs down, but we want to build that natively. Beyond that, we want some immediate support for JSON log format, whether that's coming in over syslog or flat file, so that there's a number of applications out there that'll write to it. We want to be able to onboard that just like you would normal flat file or syslog. And finally, beyond the ones listed above, we want to just be able to rapidly introduce new log sources as fast as we can get the MDI out there for them. So what does that look like? How do we accomplish that? And that gets us into Elastic Beats. Now, in a typical Elk stack, it's Elastic, Logstash, Kibana. And Elastic has since added this Beats concept that I'll talk about in a second. But instead of going from the beat into a Logstash or a beat into Elasticsearch, we're going to do some normalization and map that structured object to the Logarithm schema. In order to support backwards compatibility, we're going to have this data collector component internally, calling it Next Gen Data Collector. I think we're just going to call it Data Collector in the future. This is going to send to a system monitor agent over syslog, and that's how we get that backwards compatibility. In the future, we're looking to go directly from this data collector into the rest of the logarithm send, probably to the data processor, but it enables us to skip the system monitor agent and the regular expression-based processing because we've already extracted the relevant metadata that we need from the structured object. So this is probably in an 8x release that will be skipping a good chunk of the system, and then once you upgrade to that 8x release, you'll go from sending logs from the data collector to the system monitor agent to directly to the data processor. The exciting part about that is all of this machine data intelligence we're building out in a mapping from the structured object to the logarithm schema is all going to be reusable. It's just an output function, whether we're sending syslog or a structured object to the data processor. So I talked about beats. What are beats? I stole this really cool graphic from the Elastic site, so I hope you enjoyed it. Beats are lightweight, single-purpose data shippers. So you'll have a beat that does Azure Collection. You'll have a beat that does G Suite Collection. You'll have a beat that Elastic provides that is the file beat that just collects logs from a file. They're really cool because they're independently shippable and scalable. So now you can get updates to Azure Collection without updating your whole data collector or your whole send. They're also independently scalable. Question?
These beats maintained by you guys, are they maintained by the open source community, are they maintained by Elastic? Is it some combo?
The question was, are the beats maintained by Logarithm or the community or Elastic? That's a great question. The short answer is all three. The longer answer is I'm going to talk about that on the next slide. So the other part of beats is all they're responsible for is the authentication to the API, the paging aspects of it, and sending that structured log downstream. So again, in an Elk stack, that might be directly to Elasticsearch. In our case, that's going to be on down to the data collector to take that structured object and do the transformation to the logarithm schema. So, existing beats. This is where we get a lot of efficiency gain from using those commoditized beats. I think we're getting a new clicker in the back, is that right? Yes. Oh, did it start working?
It almost looks like it is.
All right, I think I'm just not hitting the buttons hard enough. Technology. I think we're good, so thank you. Official beats, things that Elastic supports. The file beat, the winlog beat, those are the top two ones. So we're going to use the file beat to pull in JSON files. Now, talk a little bit later about what our strategy is long-term to deprecate some of the things off of our system monitor agent, like Windows event log collection. But suffice to say, there's great technology out there that's officially supported by Elastic. Our next set of beats are community beats, so things that have already been built by folks in the Elastic community. Great examples there are Google Compute support through PubSub and Stackdriver, better CloudTrail support, Kafka, Docker, Protolog, so you can get JSON over syslog. And finally, there are beats that don't exist today. That includes G Suite, believe it or not, Azure, Cisco AMP for endpoints. So we're going to build those and contribute back to the Elastic community with those. And so that builds out that ecosystem. So for the top devices, we may be able to pull off a community beat or pull off a logarithm beat. Now, our supportability model, to answer that question in more detail, is going to look similar to what we do with Smart Response today. So we have logarithm certified and community certified, where we might have a community beat like Docker that logarithm hasn't certified. One of you picks that up and writes some of the MDI transforms for it, posts it on the community with some help articles. That's great. That's a community supported and certified beat. We see that's getting a lot of traction and customers are heavily utilizing that. We'll pull that in. We may make some changes to the MDI. We'll probably QA it in our own systems to assure the quality. We'll make sure our support's trained up on it, and then it'll become a logarithm certified beat. So that's what our model's going to look like, and we want to use especially the community and your internal CRMs and sales engineers and professional services to keep that feedback coming to us on what is most important to you. What can you not pull in today that you need to be able to, and what can you pull in today that's not meeting all of your needs? Of course, you're all wondering, when can I get my hands on this? Well, right now we're undergoing a small closed beta, so we've got a couple customers we're testing this out with. They're working directly with the engineering team. We'd love to pull in more customers for that, but we just don't have the bandwidth to. So as soon as we get to a stable product there, and we may say, hey, as soon as we have G Suite and Azure, maybe we don't have GCP or the generic JSON support, but we'll roll out an open preview to that. So it's not quite going to be GA. We may be missing things like CCFIPS and HADR support, but we want to get that functionality out to you as soon as possible, as soon as we're assured that we have a quality product out the door that you can install and get support for some of these top interfaces. We're targeting that roughly for Q1. Now, that can move up if we find, hey, G Suite, Azure working perfectly the first time we deploy them to our beta customers, thumbs up, we're going to send that out for community preview. Or, yeah, we've got a couple things to work on here, the configuration experience and some of the troubleshooting and diagnostics. We're going to hold it back for another couple weeks before we send it out to the masses. Licensing is another key piece here. And those two are your licensing gurus right there, Larry and Eric. But what we're talking about is we want you to be able to get as much data as possible into logarithms. So we don't want to charge additional licensing fees for this new data collector. As long as it's going through a System Monitor agent, that'll be the case. You will need a System Monitor Agent Pro license for that, but hopefully everybody, if you're in a small environment, you have one that's not completely overloaded. If you're in a larger environment, you might have a spare license laying around that you can spin up a dedicated System Monitor agent to collect the syslog from.
Is for the pro that's collecting it, Windows or Linux, doesn't matter which?
So, great question. Right now, the data collector itself is Linux-based, and we want to get customer feedback on, is that going to be sufficient, or do we want to build a Windows version of that as well? The System Monitor agent that collects it, we're thinking needs some capabilities like log source virtualization, which is only offered in Windows. Now we're working on better virtualization support that may be coming to Linux agents sometime around Logarithm 8, so that may be a potential solution. But for the earliest beta customers and probably even the earliest sets of preview, we're going to recommend the Linux data collector sending to a Windows System Monitor Pro agent. So that's one of the things on preview versus GA, working out some of these nuances on, is that going to work for everybody, or do we have a large chunk of our customer base that says, no, I'm not messing with a Linux to a Windows environment. Any other questions before we roll into demos? Cool. Larry, Eric, anything to add to that, some of the goals we're trying to accomplish? If you think of anything, feel free to chime in.
Okay.
So, my first demo is going to be all about just regular old JSON. So what I have up here is some carbon black JSON, side by side, 2 log samples, something you might find in a syslog message or a flat file. And the first thing that I want to highlight here is that domain is a field that appears in the first sample but not the second sample. In addition, we have some fields here that are out of order. Event type appears first in one log and second in one log. Now, this is really simple JSON. There's not even any arrays in this JSON, but if anybody in this room can write a performant regular expression on this JSON to handle both cases, we're hiring. So come talk to me afterwards. So what do we do with this JSON? Well, we've got concepts of filters and transforms. So what we'll do in the data collector is say, I want to apply this transform to any log that is carbon black inbound. Because if it's outbound, I'm probably going to switch from SIP to DIP, and I'd probably have a separate transform for that. But all I'm going to do is say my beat name is carbon black, that's just a string, and I'm going to map a logarithm field, like vendor message ID, to the event type field that comes from the carbon black JSON. Now, if this was nested JSON, if I had an object inside of an object, it would just be event type dot name. So you can go into the JSON in tiers, and I'll have an example of some very terrifying, ugly JSON later on, and how we actually handle that JSON. That's one from G Suite that contains arrays and embedded objects, and so we're working through how we're going to support everything from very simple JSON to very complex JSON. Now, what you see down here at the bottom is the log message that gets sent over syslog, and what we do is a consistent order, very efficient string that is pipe delimited that gets sent over syslog to the message processing engine. Now what this does mean for backwards compatibility is you need both the transform and a simple MPE rule. That MPE rule is responsible for taking the values and sticking them into the schema fields and assigning the common events as well. So for the first pass of it, it's going to be a manual, build the transform, build the MPE rule. They're not going to be too hard to build because they are very simple. In the future, we're looking at building out the tooling that says, I'm just going to build my transform and it's going to export everything for me. And that may even be some sort of a UI. And that's something we're looking for customer feedback on. How many of these do you think you want to build on your own versus how many we're going to build internally? And what sort of tooling do you need to be successful there? So let's take a look at that JSON in the web console. On the right-hand side, I have the log message that got sent down to the system monitor agent and into the message processing engine. And here on the left side, I've got everything that we extracted from there, from the source IP address to the vendor message ID to the domain. And you can see my log source type is syslog, but I've called it the data collector beta carbon black JSON. Any questions on generic JSON before I move on to Azure?
I got a question about, if you could back up. Your priority and facility were kernel emergency. How did you get that out of your JSON?
That's the syslog.
Yeah, that's the syslog header.
I know, but how did you generate that priority and facility out of your JSON that came out of your carbon black?
I don't think that's been touched by the version of the data collector that I used to generate these examples. There's a couple things that we're still working through is forming the syslog header.
That doesn't mean anything.
Yeah, this screenshot was more to illustrate the pipe delimited nature of it, but that's a good point. The time is also a key aspect in here on how we extract a time from the log message and send that down so that we get a normal log date and essentially what logarithm calls true time through the system. So, Azure Monitor, we had a lot of hands go up when we talked about Azure, so I like this demo. Azure Monitor is one of Azure's monitoring capabilities. They do have a lot. There is, I guess Azure Monitor is what they're going towards. So there's a number of terms that just trying to keep them straight. We've got Azure Monitor, which is their monitoring hub. Inside of Azure Monitor, you have an activity log, which can sometimes be called the control plane. So anytime you interact with a resource from the outside, like create that resource, update it, delete it, that's going to generate an activity log. And it does give you pretty rich, useful data. Virtual machines and key vaults and network security groups, when people are creating those or updating them. That's not to be confused with the diagnostic log, which is that second part of Azure Monitor. That is anytime you're doing something inside of a resource, like network security group, it'll roll up how many logs or how many packets are hitting certain rules inside of it. Key vaults, anytime I read a secret from a key vault or read files from a storage, that's a diagnostic log. So activity log is actually really easy to get at. We're using the technology called Azure Event Hub, and our connector is an Event Hub connector that reads Azure Monitor logs. So all I have to do to get Azure Monitor into Event Hub is click this export button and tell it what Event Hub to send it to. Super simple, sends them all down. If I want to do diagnostic logs, I have to come into the, I believe it's the diagnostic settings, but it may actually be a menu lower down, and it's going to give me a list of the resources in that resource group, and I have to go through resource by resource. There's no bulk change, and say I want to send these types of diagnostics from this resource to the Event Hub. So that's something we're trying to work with Microsoft a little more on what their roadmap looks like to make that an easier process. They do have some policies that you can put in place to help you audit what you have diagnostic settings turned on and off for, and activities like if I want to spin up a new VM to make sure diagnostics are enabled correctly. Now the other area there is the OS level diagnostics like Linux syslog and Windows Event Log. For the time being, we're still recommending putting a logarithm agent in the environment and forwarding to that agent for those OS level diagnostics, because there's no way outside of using Visual Studio to send any of the diagnostics from an OS inside of an Azure VM to Event Hub. Microsoft's promising that early 2019, so we're going to wait for that and have some recommendations for it once that comes out. So the activity log, I captured some stuff. Here, it's just a JSON blob, and there's a ton of information about who the claims, really who authenticated to this, IP address. As I scroll down, you'll see resource type and resource group name. Things about the tenant. If you're running multiple subscriptions inside of Azure, you get that level detail. So this is not a final Azure transformation, but these were fields that I found interesting inside of the activity log and said, I want to call this authorization action the command. So again, the transformation is really simple. I'm just saying a logarithm field is this Azure field. And what I was able to do is populate my own Azure dashboard. And this is just my test system data, so it's not super rich, but it still gives me great visibility into what's going on inside of the Azure environment. Host origin, the users that are doing things, the objects, and you don't get a whole lot of visibility here because the objects there are so long, but an object gives you the information about the resource group and the tenant and what's actually going on. So now I'm going to look around at some logs inside of there, and I just picked out a virtual machine restart, and you can see the action and the object or the virtual machine that was restarted, who did it. Now I'm going to get out of my compute, and we're going to go hunting into things that failed. So what you're about to see is something I showed in the cloud presentation where I used an Azure policy to restrict what SKUs I could use when creating a VM. And this is a really good best security practice for your Azure or AWS or GCP environment, where you say, I want to restrict only these types of VMs to be used, the ones that your company needs, so that they can't spin up, somebody gets into your environment, they call it crypto coin mining, crypto jacking. They could very easily spin up a couple of the largest VMs and cost you a whole lot of money. So if you restrict that, now you can audit if anybody tries to spin up one of the restricted ones. And that's cool because you can say, hey, is this somebody on my DevOps team that didn't know we were restricted? Do we have to go back and add that to the policy? It opens up opportunity for us to maybe have some smart response actions that allow you to do some policy management, whitelisting, blacklisting directly from the web console. Or you can identify maybe this is a threat actor, somebody that got in and tried to spin up a VM without permission. So a lot of cool opportunities there, and as we start to work with customers who are onboarding Azure data, we'll have even better demos because they're going to be doing things with their Azure environment that I just don't have the capability to do inside of mine. Another area there is Azure Security Center. If you've been using that, it complements Logarithm really well because you can pull those alerts directly down into Logarithm through the Event Hub, and you could even create an AIE rule that just fires off an alarm every time you get an Azure Security Center alert with the context from that alert. And then you can do some cross-prem investigation. Maybe the actor is pivoting between cloud environments or between on-prem and Azure. And that's why you never really want to focus your investigation in one area. That's why SM exists, to pull things down to be able to correlate between. So, am I doing on time? All right, G Suite, our last demo here. I alluded to this JSON being pretty terrifying earlier, and that it is. Happy Halloween. So I'm going to point out a couple things in this JSON that make me a little bit squeamish. The first is that we have an array in here that is multiple events or multiple logs within a single response from the API. So we need to be able to handle that when we get a beat, which ideally is just a log message in every heartbeat that we get down. In G Suite's case, it's going to be multiple logs inside of that. So we need to be able to break that out. The second part in here is they have this parameters thing. So instead of saying that target user equals bruce@company.com, they say, I'm going to give you an array of things. The name of this element is target user, and the value of that element is bruce@company.com. So that makes it really challenging to write something, really writing a where clause here. I want the value where the name is target user. And the third thing is multi-values. So inside of each of those values, you could have multiple things going on here. And what you want when you're trying to map this to a logarithm schema is slightly different behavior every time. You're going to want that first array to map to a different log message. You're going to want the second one to be able to extract the name and the value from the array and really flatten it out to be able to say I want to put the target user into my user origin. And the third part here is a multi-value. You may want to delimit that with a semicolon for auditability in a single log message. So imagine trying to figure this one out at search time and doing correlation between an Azure log and a G Suite log and what that search might look like. That's why we do data normalization up front, and I think that's the real power of doing data normalization up front. So, demo of G Suite. I am going to go ahead and sign into G Suite, but I used my wrong password, so that's going to generate an authentication failure. And then I'll give it the right password, and it should generate an authentication success. Now I'm in Google Docs. I'm going to go ahead and create a new document, or object created, and then rename that document, or object renamed. Finally, I'm going to type some stuff into my document. You know, with Google Docs, one of the cool parts of that is you get co-editing and it saves very frequently, but that does cause a lot of logs to get generated. But what I can see here is those 5 steps that I called out before, everything from the failure to the login success, creating the document, renaming the document, and editing the document. And if I kept editing that document, I could get tens or dozens of those edit events. Some insight here: who did it, what IP they were from. The reason here, I got an invalid password. Maybe I'd get an invalid user if that user didn't exist. Then I can go up and look at the object created, and you get some cool stuff here between, you know, the object name is that file name, but that might change as people rename documents or move documents. But this object ID is something that stays constant throughout. And so you can do traceability or AIE rules or search to see what's going on with a specific document as it gets created, uploaded, downloaded, shared. So I think I have one more video. I'll kind of let this play in the background. It's just another demo video on G Suite, me generating events, looking at, there we go. Looking at user origins and user impacted. These slides are available on Community. You can go in and watch the video, see some of my notes. I've got some references in the appendix as well. If you have any questions, please come on up. We got a couple minutes right now, and then I'll be around the rest of the afternoon and evening, and even tomorrow morning. So come find me. If not, I'm also active on the Community, and you can ask a question there.